Oh, hi. I'm just about to blow up the universe. When the Science Museum collected the contents of the office of Stephen Hawking, the world's best-known scientist, there was something incongruous sitting on his desk next to his computer. An inflatable ball. This ball was created to celebrate one of the marvels of the modern scientific age, a feat of observation of the oldest light in the universe. So there's that hymn about holding the whole world in your hands. Well, here I'm actually holding the whole universe in my hands. Now, I must admit, I wouldn't be as cavalier as to be holding the beach ball that was actually sitting on Stephen Hawking's desk. This is a sibling of the one that we collected all those years ago. When Hawking was alive, this beach ball took pride of place in his Cambridge University office. He would present it to young visitors, of course, for them to play with. But it had huge significance to Hawking himself because it vindicated some of his most important ideas about the universe. The beach ball carries a picture of the baby universe taken by a space probe called WMAP, or the Wilkinson Microwave Anisotropy Probe, which was launched in 2001 and would end a decades-long argument about the nature of the cosmos.
The WMAP mission was a mission in cosmology, which is the study of our universe as a whole. It became clear that there was a need to make a map of the full sky in microwaves, and that if we did that, we could use this microwave map of the sky to derive essentially an entire model or theory of how our universe works from beginning to end. It sounds like a lot, but as it turned out, that's exactly what happened.
WMAP measured light radiation emitted in the hot young universe before there were any stars at all, when it was only 375,000 years old. That ancient light, a kind of cosmic fossil, took more than 13 billion years to reach the probe.
We measured the age of the universe quite precisely. We got that it's 13.77 billion years old, and note the precision of that kind of a statement. It came to pass that we measured a lot, those and more properties of our universe just from measuring the pattern of these microwave fluctuations.
There's something really surprising about the data that was gathered by the WMAP probe, because it shows that only 5% of the universe consists of the matter and materials that we're all familiar with the rest consisting of stuff that's never been directly detected in the laboratory.
Well, it turns out from WMAP we learned that 25% is something we called cold dark matter, and then the bulk of it, the remaining 70%, is something we call dark energy. So basically, if it says dark in the beginning, it means we don't understand it.
The ball's colors show the temperature variations of light within the baby universe, with red as hotter and blue cooler. The prominent red stripe visible around the equator is a more recent, closer and hotter foreground signal that comes from our own galaxy, the Milky Way. Stephen Hawking's thinking about the data here dates back to something called inflationary theory, a really big idea about the universe that dates back to work by Alan Guth in 1980 at Stanford University. And inflationary theory says something really mind-boggling about the earliest moments of the universe. In those moments, the universe expanded from being something like a billionth of a meter across into something like a quarter of a billion light years across in something like a trillionth of a trillionth of a trillionth of a second. This mind-boggling growth spurt stretched out the universe rather like snapping a sheet tight, making the universe look quite similar in many directions. At a seminal workshop hosted by Stephen Hawking in Cambridge in 1982, details of inflation and how these irregularities on the beach ball arose were worked out in detail. Now, to understand the large-scale structure of the universe, you need a theory of gravity, and that's Albert Einstein's theory of general relativity. But to understand the baby universe, when it was absolutely microscopic, you need a different kind of theory, and that's quantum theory, which rules atoms and molecules. And it turns out that tiny quantum fluctuations seeded slightly different density variations in the early universe, and these triggered the coalescence of material as gravity pulled that material together. And over the billions of years of the universe, that turned into all the structures that you can see around us in the night sky, from galaxies to stars to you and to me. WMAP's evidence for inflation was at that time the most exciting development ever to have taken place in physics, said Hawking.
This map allowed us to put together in one place, in one way, with a really a physics measurement, not guessing or stabbing in the dark at things, but in a physics measurement. This map let us put together a coherent whole of cosmology.
Some say that Stephen Hawking himself was more excited by this finding than he was about black holes, notably his revolutionary discovery that black holes give off radiation, now called Hawking radiation in his honor. So this mottled pattern here, Hawking regarded it as a kind of blueprint for the cosmos, as the kind of fingerprints of creation. So what does this beach ball really tell us about the universe? Well, what excites me is that cosmology and science often deals with big, abstract, intangible ideas like general relativity and quantum theory. But this playful object reminds us that at the end of the day, it's about our surroundings, it's about our environment, it's about where those patterns of light in the night sky come from, and ultimately where we come from as well.
So remember to look up at the stars and not down at your feet. Try to make sense of what you see and hold on to that childlike wonder about what makes the universe exist.
If you enjoyed this video, then please do like and subscribe to the Science Museum YouTube channel. And if you want to find out more about the contents of Stephen Hawking's office, which have got amazing stories to tell, then do rush out and buy a copy of my book, which has got a foreword written by the Nobel laureate and Stephen's first collaborator, Sir Roger Penrose.